Hi there, it's Joseph Asukwo, and welcome back to my YouTube channel. It's still Golang for beginners. So we have started a series of a series of blockchain, how to transition from a Golang developer to a blockchain developer, right? You don't need to know anything about blockchain. This is we have started this playlist, this blockchain playlist. So you should, this is the blockchain playlist. Right now we have two videos in it. So right now we are about to enter the third video. This is the third video for the blockchain playlist. So if you haven't already, please go ahead and subscribe, um, comment, like, even share with your friends, and so that they can also learn and we can grow this community together. And if you have any topic you need to be treated, you can send it to me. I will be glad to do so, right? This helps me, keeps me motivated, and keeps me coming back to do more. Please go ahead and subscribe. So back to our topic today. So like I said, we have been talking about blockchain as a whole, and in our last video we spoke about what a block is, how to read a block, how to get the latest block, how to read transactions in a block. We even did it through code. With code, we played around with we visualized a transaction hash. We talked about the hash, the receiver, the value, the gas price, which we all saw this using Golang code, right? So please, even if you have watched it before, it's always good to go back and then rewatch it, repractice, because that is how you can be perfect. Practice makes perfect. If you haven't, don't just start and stop here. Go back to the previous videos in the playlist and continue from there. Yeah. So today we are going to talk about core things about blockchain, Ethereum blockchain, things like an account, a nonce, and stuff like that. So let's get to it, right? The question is, what is an Ethereum account? Like, what is an account? Basically, not just an Ethereum in blockchain, what is an account, right? Basically, we have two types of accounts, right? And they are ex- externally owned account and a smart contract account, and both have an address, and they both and they both behave differently, right? So basically, your address marks an address marks an account, and there are two types of accounts: externally owned accounts and then the smart contract account, right? Put that in mind. I'm going to show you how as we go on. So the question is that what is an externally owned account? An externally owned account is controlled by private key, right? Example, this is your account you get from things like MetaMask and whatever, right? You get from MetaMask. It's an externally owned account. You have a private key that is assigned to only you, right? To that only that account, the private key that is assigned to that account. So what can the accounts do? These are the accounts you use to send and receive Ethereum. And if you are working on a smart contract account, you use this account also to deploy such smart contracts, right? Deploy contracts, and then you can you can also use such accounts to call contracts, right? It's as easy as that. But the thing is that it needs a private key, and we can quickly just show that here. So I'm just going to switch back to this tab, and let's go to my MetaMask. So this is my MetaMask, right? This is my account. Basically, this is my address, and this is my externally owned account. You can use it to I can use this to accept get paid, accept ETH, or receive ETH or send ETH. This is what this account is used for, right? I hope there is no confusion there, right? So, and then again, we will now take a look. So the next one is called a smart contract account, right? This is a smart contract account, and the question is, what is a smart contract account? A smart contract account is easily just is you just saying, user, you write a smart contract. Like I said, in here you could say that you can use this your externally owned account to deploy contracts. So that contract, yeah, the contract you deploy is as good as a smart contract, right? It's as good as a smart contract, which is this. So these smart contracts have business logic. On its own, it has business logic that governs that account per se, the smart contracts account, which I'm going to try and show some a sample there. So what is it? A smart contract cannot sign transactions. That is done by the externally owned account. That's the one I just showed you on MetaMask. It cannot exist without an externally owned account triggering it, right? It's just there to execute code automatically. So a contract is a contract. It's just an account that whoever is involved in this contract is binding to this contract, right? Examples is the ERC20 token, NFT contracts. You might have heard of all these things, marketplace. So let me show you an example of a marketplace that is probably using a smart contract, right? Let's go to dap.propchain.io, right? Let's close this MetaMask. Let's go to dap+.propchain.io. So now you can see this is a marketplace. This is literally a marketplace that is being. So how this marketplace works is that it's being connected to a smart contract, right? So we saw here that it cannot exist without an externally owned account triggering it. So that's why when you come to a marketplace like this, they're going to ask you to connect your wallet, what that means is connect your externally owned account. So if you click here, you would see I can connect with my MetaMask or Tron or whatever wallet, but MetaMask is can be connected. And then let me see if I should just connect it and then connect. Then that's it. Then I can now buy prop C, which is on that contract. So if I buy it, it's going to go to my wallet, right? So that's how a smart contract works, and that is a that's how a smart contract account works. So it's just there to execute the logic on that account, on that smart contract. I hope that's clear. If it's not clear, you can always ask question in the comments section, right? So the next would be, what is a nonce? I don't know if I spoke about nonce in my previous video, but nonce is very important when you're sending transactions, right? It is a transaction counter. So if you have an externally owned account, every transaction is going to start from a 0. So your first transaction is going to be a 0 nonce, and this next one is going to be, your second one is going to be nonce 1, then the third one is going to be nonce 2. The question is, why is nonce important? Because you get this a lot when you are talking about blockchain as a whole. When you are talking about blockchain as a whole, and then you're doing interview, they ask you a question like, why is nonce important? Why it's important is because it prevents replay attacks. So the question is, what is a replay attack? Yeah, that's what you'll be asking. So we all know that the blockchain is immutable. That means you can't change it, right? And whatever is in the blockchain, everybody might have access to it. Everybody probably gonna see the transactions on the blockchain. What stops me from executing the same transaction 2 times? Maybe I intercept your transaction that I'm seeing on the blockchain. I intercept your transaction which has a nonce 0, and I'm trying to send the transaction again to the blockchain. It's going to check, okay, this is nonce 0. The next nonce shouldn't be nonce 0. It should be a nonce 1 or a nonce 1. So it's going to reject that transaction. And then the next question you're asking is, what if I just change the nonce from 0 to 1, since I already know it's a nonce 0, and then I can send it back? Then the answer is that since the blockchain is immutable, anything you change on that transaction will be invalid, because it's going to check, has this been changed? Is it the private key assigned to it that is making this transaction or changing the transaction? Then the answer is no. Then it's going to be invalid also. So that's why nonce is very important. It's a very important concept in blockchain. Then, so what do, like I said, why do we need nonce? This is just it. Imagine Alice sends 1 ETH to Bob. Someone copies that transaction without a nonce. The same transaction again could execute again. The same transaction could execute again. Nonce prevents replay attacks. It also keeps transaction in order. Like I just said, I just explained what a replay attack is to you. And transaction in order, at least you know after 0 is 1 is 2, you know how many transactions you have done. So basically that's it. So the next concept we are going to touch is the concept of gas, right? Gas is just a measurement how much computation a transaction performs, right? For example, think of gas as a fuel in a car. You're just thinking of it as a fuel in the car. How much fuel will it take a car to drive from direction A to direction B, right? That is basically the concept of gas. So gas is the same thing. How much does it take Ethereum to what do you call it, to execute this transaction or this order? If it's a smart contract transaction, execute this smart contract logic, or execute this send transaction that you want to execute from your account. That's basically what a gas is, right? So the concept of gas is that you need to know that there's something called gas limit and gas price, right? So a gas limit is the maximum gas you are willing to use. For example, you're about to take a trip from distance A to distance B. You know the distance between distance A and distance B. So in your mind, you fill the car full tank. You put the car like 30 liters of fuel in the tank, because you feel like, okay, you should get from distance A to distance B in, it shouldn't be up to 30 liters, but you are willing to forgo 30 liters, right? So what happened is that if the distance between A and B is more than the 30 liters of fuel gas that you put in your car, then your car stops halfway. You can't complete that transaction. You cannot complete that journey because that is the limit, the gas limit you wanted. You said, okay, this is the gas limit. So it's the same thing here, right? You need to specify when you're calling a transaction. There's a way to specify what is the maximum gas you are willing to use, right? And also, how much are you willing to pay per gas, right? How much will you pay per unit of gas that you're willing to use? And this in total, this concept, right? So specifying the maximum gas you are willing to use doesn't necessarily mean that all the gas should be used. For example, now you are going from distance A to distance B, and then you put a full tank of fuel in your car. You're saying the maximum it can happen that can be used is a full tank of gas. But if it gets there in 10-20 liters, then gas use would be the 10 or 20 liters that has been used times the amount of money you paid per unit of that gas. And that is what gives you fee. When we're talking about fees in blockchain, this is how fees are gotten, the concept of fees. So for example, right, automatic the basic gas for sending a transaction, maybe a transaction in an externally owned address, is usually 21,000, right? That is, so if you're using like a MetaMask or a other wallet, it's gonna calculate that for you automatically, or you can change it or vary it as you like, right? So now 2 GUI here, which is like the least you need for ETH, is you saying, okay, I'm willing to pay up to 2 GUI per gas. So what that helps you does is that when there is high traffic, right, people that are going to validate your transaction, right, the system that's going to validate your transaction is going to validate it based on what they can benefit from it. So someone that is paying 5 GUI per gas, right, is going to obviously get transaction is going to be attended to first before yours. So you might need to wait a bit before you get confirmation, before your transaction is confirmed on the blockchain, right? We will get to all those mechanics later in this course, hopefully, right? So that is the concept of gas and fees, right? If you're still if you still don't understand, you can always reach out to me and I can explain better, right? So now the question is that why would a transaction fail? Why would a transaction fail? So most transactions would fail for several reasons. Wrong nonce, like I explained to you, if the blockchain checks, okay, this is a wrong nonce. The nonce that was used before was 0, so the next nonce for the next transaction should be 1, not 0 again, or not 2, not 3, in that order. Then it's gonna fail, right? Now, gas limits too low, right? If like I said, if you are supposed to go from the stand A to the stand B, and then the fuel you are specifying as the limit is just 30 liters, and that this from the stand A to the stand B takes more than 30 liters, you're not going to get to your destination. It's gonna fail. Gas limit too low. Then there is insufficient balance. Obviously, you can't be sending money that you don't have. You cannot be making a transaction you don't have. If you don't have money to pay for the gas, then you can't be making such transaction. And then smart contract reverted. So there are ways, there are concepts in which this, like I said, smart contract is an account, so there might be logic that would cause it to revert, right? To revert, so and the transaction fails, right? So today's code would be quite simple because we have literally shown most of these concepts in our previous video. So you might make sure to check it out, right? We have shared it in our previous video. So I want us to understand the concept of nonce, and maybe pending transactions, right? So which kind of like explains the concept of nonce better, right? So now let's switch back to code. We are still using the same code base. You can check the description and pull it and get to play along with it, right? So this is it. It's as easy as you okay, this is it. So we already explained this concept last time. So when we did, we printed the different things, the receiver, the value. Now the gas price, you can see the gas price is different from the gas, which I did explain what the gas price is and what the gas is, right? So gas, for so the difference between gas is just the measure of how much computation a transaction performs, right? Like the fuel. Then the gas price is how much you are willing to pay for the gas that is being used, for the fuel that is being used, which is in turn would make me want to pick up your transaction faster, right? Now nonce is here. We can also have access to nonce here. So then the hash is, so let's just take away what doesn't, the concept we don't want to refer to here, and stick to let me just leave the ID so that we can track it. So let's do go run main.go, go run main.go. Let's see what happens. So it has connected successfully. The next thing is supposed to try and pull the latest block number. I mean, if you were following my previous video, you would understand, and this is the latest block number, which we checked that out in our previous video. So now you can see for this transaction, let's say the transaction ID. For this transaction ID, we can see the gas price was this, the gas limit, this is the gas limit. Probably this is just a send. They're probably sending from one wallet to another, which is a standard 21,000, which I did show you here, 21,000. So now the fee, the total gas fee for that transaction is probably going to be this gas limit that was used times the gas price, and that's what you see. And this is the nonce. So if you check the next, so if it's sending, if this same sender wants to make another request, send another transaction, the nonce will have to tally with 495596, right? So using, let's also comment this out again, right? Let's comment the transactions out, and let's uncomment this. Let us uncomment this. Let's take away the block. We don't really need it anymore, because I just want to show you. So this is my address. Okay, this is my Ethereum address. This is my Ethereum address. We can confirm that with my MetaMask DX3DB8, which is here on my MetaMask. D3BD82, which is the same thing here. So what we are going to do is that we are going to check out what my nonce is this, yeah. So we can easily just check out what my nonce is. Besides, I'm using this wallet for just visual training and testing purposes, right? So this is going to be my nonce. If I do go run main.go, so for that, my address, so I'm going to check that address out, and then my nonce is 2. As you can see, I've already done one transaction. This is my pending nonce. My pending nonce is I've already done 2 transactions, so my pending nonce would be 2. So if I'm going to do another transaction, I would have to use 2 as the nonce, because blockchain is going to realize that, okay, I have done a nonce 0, a nonce 1, so now this is a nonce 2, and if it keeps going, it's going to keep going to 3, 4, 5. So I know this was more theory than practical, right? But I hope you understood the concepts, because in our next video we are probably going to go into sending and receiving Ethereum, right? So that, but before that, you need to follow along, understand the concept, so that you won't get lost, right? Thank you again for tuning into my YouTube channel. I hope you learned a thing or two. Feel free to reach out to me with your questions, and please subscribe, like, comment, share. This keeps me excited, this keeps me motivated, and thank you. Let's grow this community together. Thank you very much.